Welcome to Spaceverse, your portal to cosmic adventures. 160 scientists are finding unexpected things in the latest images from the James Webb Space Telescope. These discoveries suggest the universe might not be what we thought it was. The strange new observations are challenging everything we've believed so far, from dark matter and dark energy to the very origin of the cosmic microwave background radiation. According to researchers, the Webb telescope is uncovering something big, something that could completely change our understanding of the universe. Andre Kudel, a postdoctoral researcher at the Lawrence Berkeley National Laboratory in California, summed it up perfectly when he said, "We're in the business of letting the universe tell us how it works. And maybe it's telling us it's more complicated than we thought." In this video, we're going to break it all down step by step. Trust me, it's going to blow your mind. To understand why these new discoveries are so groundbreaking, we first need to revisit a few fundamentals. According to the laws of gravity, its strength weakens with distance. For example, the sun's gravitational pull on Mercury is much stronger than it is on Pluto or any other distant object at the far edge of the solar system. This principle isn't limited to our solar system, it applies universally. From stars and galaxies to black holes, the farther away something is, the weaker the gravitational pull should be. That's just how physics is supposed to work. But in the late 1900s, scientists found something strange. Astronomers began observing galaxies more closely, especially in the 1970s, thanks to the groundbreaking work of Vera Rubin. She discovered that stars far from the centers of galaxies were moving just as fast as the ones closer to the core. This shouldn't happen. If stars are orbiting too fast at the edges of galaxies, they should be flung into space, just like water flying off a spinning wheel. But instead, the stars stayed put. Something was keeping them in orbit. The only explanation was that there must be an unseen force, a hidden source of gravity, pulling on them. Scientists called it dark matter. Now, dark matter doesn't mean dark as in evil. It simply means we don't know what it is. We can't see it, we can't touch it, and we don't know what it's made of. But the evidence for its existence was overwhelming. Dark matter became the invisible scaffolding of the universe, the glue that held galaxies together. It also explained how cosmic structures formed. After the Big Bang, normal matter began to clump together under the influence of dark matter halos. Over billions of years, galaxies emerged and evolved, creating the vast cosmic web we see today. Even the ripples in the cosmic microwave background, the faint glow thought to be the afterglow of the Big Bang, show clear signs of dark matter's presence. But here's where things get strange. The James Webb Space Telescope is now challenging all of this. In its latest images, Webb has found galaxies at record-breaking distances, further back in time than ever before. The deeper we look into the universe's past, the more galaxies we find. And that's a huge problem for the current dark matter model. Why? Because these galaxies shouldn't exist this early. Take MOM Z14, for example. This galaxy existed when the universe was less than 280 million years old. That's incredibly close to the supposed beginning of everything. Even more astonishing, scientists have found candidates at redshift values of 20 and beyond, meaning they may have formed when the universe was just around 200 million years old. And here's the kicker. Some of these galaxies aren't small or primitive like we expected. They look well developed, some even larger and more mature than our Milky Way. One galaxy, named J0107a, is about 10 times larger than the Milky Way. Yet it formed just a few 100 million years after the birth of the universe. This is the largest Milky Way-like galaxy we've ever seen in the early universe, and it just doesn't make sense. According to our theories, galaxies should take billions of years to grow that large. But Webb is telling us otherwise. If dark matter truly shaped the universe, how could such massive galaxies already exist so early? Either we've misunderstood dark matter entirely, or maybe it doesn't exist at all. But it doesn't stop with galaxies. Webb has also revealed something even stranger, mysteries involving the largest cosmic structures in the universe, like galaxy clusters and filaments. This puzzle is known as the S8 tension. S8 is a value that measures how much matter clumps together in the universe. It helps explain how galaxies and clusters spread out and evolve. When scientists use cosmic microwave background data, they calculate one value for S8. But when they actually observe the present-day universe, they get a lower value. This discrepancy might not sound huge, but it's statistically significant and consistent. That means it's not just a fluke or measurement error. Something deeper is happening that our current models can't explain. And that's not all. Dark matter isn't the only mystery under fire, dark energy is too. For decades, scientists believed dark energy was a constant force driving the expansion of the universe. But Webb's observations are adding fuel to an already growing debate known as the Hubble tension. When we calculate the universe's expansion rate, the Hubble constant, using the cosmic microwave background, we get one number. But when we measure it using supernovae and nearby galaxies, we get a completely different number. The mismatch is so significant that it could mean dark energy isn't constant at all. Instead, it might change over time, something we still don't understand. And now comes the biggest twist of all. The cosmic microwave background itself, the cornerstone evidence for the Big Bang, may not be what we think it is. Traditionally, the CMB has been seen as the afterglow of the Big Bang, the first light of the universe. But new research suggests it might instead be the combined glow of billions of early galaxies. Here's how: early-type galaxies, filled with young, hot stars, produced huge amounts of radiation. Over billions of years, this radiation could have stretched out, redshifted, until it looked exactly like the CMB we observe today. This means the CMB might not be a relic of the Big Bang at all. And if that's true, then the foundation of modern cosmology is suddenly on shaky ground. Even a small contribution from early galaxies, estimated at about 1.4% of the total CMB energy, is enough to complicate our interpretations. And if their contribution is larger, it could mean the entire concept of the CMB as Big Bang evidence has to be rethought. As if all this wasn't mind-bending enough, Webb has also observed another anomaly: galaxy rotations. In a survey of more than 30,000 galaxies, scientists noticed that most of them rotate in the same direction. According to the Big Bang theory, the universe should have formed chaotically, with galaxies spinning randomly. But instead, there's an eerie alignment. Even stranger, the further back in time we look, the stronger this alignment becomes. In the universe's earliest stages, galaxies were even more uniformly spinning in the same direction. This can't be explained by current cosmological models. It suggests the universe itself may have had an initial spin, something our theories have never accounted for. And that brings us to perhaps the most radical idea of all: the possibility that our universe exists inside a black hole. A recent study in Physical Review D by researchers at the University of Portsmouth suggests that instead of beginning with a singularity, the universe might have formed from the collapse of matter into a black hole. Professor Enrique Gastiaga explains that matter collapsing under gravity doesn't always reach an infinite point. Instead, it can rebound, triggering the birth of a new expanding universe. In this scenario, the edge of our universe is actually a black hole's event horizon, preventing us from seeing anything beyond it. The cosmos becomes part of an ongoing cycle of collapse and rebirth, a loop that could continue forever. This idea also aligns with conformal cyclic cosmology, proposed by Nobel laureate Roger Penrose. According to Penrose, the Big Bang wasn't the absolute beginning. Instead, our universe is just one of many cycles, or eons, each giving way to the next in an eternal chain. When you put all of this together, it becomes clear that the James Webb Space Telescope isn't just helping us look deeper into space. It's forcing us to rethink the very nature of the universe. From dark matter and dark energy to the cosmic microwave background to the possibility of a black hole universe, everything we thought we knew is now under question. And maybe that's the most exciting part. The universe is far stranger, more complex, and more mysterious than we ever imagined. Webb has only just begun its mission. Who knows what else it might reveal in the years ahead? That's it for this video. I hope you enjoyed the journey. The James Webb Space Telescope is showing us that the universe might be far stranger than we ever imagined. From galaxies that shouldn't exist to cosmic structures that defy explanation, even the very beginning of everything is now up for debate. One thing's for sure, our story of the cosmos is only just beginning. This is Spaceverse, where the mysteries of the universe are never ending. Until next time, keep looking up.